Okay, so today, students, we're going to be reviewing quadrilaterals. There's lots of different types. A quadrilateral is just a four-sided shape, and then we try to be as specific as possible in naming them when we can. That's why there are squares, rectangles, rhombus, parallelogram, kite, and a trapezoid. So what makes a trapezoid an actual trapezoid? You can see that definition. It says it's a quadrilateral with exactly, and that should be one pair of parallel sides. Okay, and a kite on the other side is a quadrilateral, with two pairs of congruent adjacent sides and opposite sides that are not congruent. So you can see if you look up the tree, a four-sided shape is called a quadrilateral. So that's all four-sided shapes. And then from there you can have a trapezoid. So follow the path to the trapezoid. And there are different kinds. You can see there's an isosceles trapezoid as well as a right trapezoid. And then you can follow on the opposite side of the quadrilateral and you see a kite. But going down from the quadrilateral, we have a parallelogram. A parallelogram is a quadrilateral with opposite sides that are parallel and they are congruent. That is important to note. So that should be congruent. Okay, and then you'll notice from there that if it's a parallelogram, then there are some different names that go along with that same definition. So they are also parallelograms technically, but the most correct name would be a rectangle, which again is a parallelogram, which is still a quadrilateral because it's four sides, with four right angles. And on the other side, you have a rhombus, which is a parallelogram, but it has four congruent sides. And a square is a parallelogram with four congruent sides and four right angles. So when you think about it, a square technically has five correct names, but a square is the most correct. So if somebody said that a square was a rhombus, they are correct. If someone looked at a square and said the square is a rectangle, they are also correct. If they called the square a parallelogram, they are correct. And if they just called the square a quadrilateral, they would also be correct. However, the most correct name is a square. So we always try to use the most correct name. Okay. Now, if you look at any of the quadrilaterals, it doesn't matter which one. If you were to draw a diagonal line, maybe I will draw a diagonal line. There we go. Then you have two triangles. And if a triangle is 180 and a second triangle is 180, that means that all angles, all four angles in any quadrilateral will have a sum of 360. Whoops, let's fix that. 360 degrees. Okay, so 360 degrees. So you can think of it as angle 1 plus angle 2 plus angle 3 plus angle 4 must equal 360 degrees. Okay, so finishing looking at our next. Okay, so we also need to remember our quadrilateral formulas. So you guys should all be able to draw a rectangle. I could make these perfect, but I'll draw them just like you. I'm going to put my four right angles. And then I'm going to mark the sides that are parallel to each other with different markings so I know they're the same. And the long side we call length and the short side we call width. So our area formula, which we should have memorized, is length times width. If you would like to call it base times height, that's still correct. So you could make that B and that H. That would also be fine. On a parallelogram, if we were to draw our parallelogram, it's kind of like a rectangle that it looks like someone's come and pushed sideways a little bit. So here's my parallelogram, and usually they have little arrows telling you, you know, this line and this line are parallel to each other, and then this line and this line. My triangles are getting a little off, or my arrows. Those two are parallel to each other. And then we can classify the height either inside, and again, they have to be perpendicular, making that 90-degree angle. So here's my height, and then this would be the base. Or you could do it along the outside. So sometimes they'll have the dashed line on the outside. And so there's our 90-degree angle, and the height would be over here. However, the base would still be the same. Okay, so that's not going to change. So our formula for that, our area is base times height. Okay, for our square, we have 4 sides that are the same, so try your very best to draw your picture accurately. So angles, 4 right angles, 4 congruent sides. Okay, and because it's just the side length, we just call it S, and so our formula is the side squared. Okay, remember that's the same thing as side times side. And our last one for a trapezoid, I'm going to draw the trapezoid that most of you recognize as the trapezoid, and that's more of like an isosceles trapezoid. So we'll draw this, and there is a formula. So if this is my trapezoid, that means this line and this line in my trapezoid are parallel to each other. My height would be on the inside, making that 90-degree angle. So this is the height. And then we have base 1 and base 2. So our area formula for a trapezoid would be 1/2 the height times base 1 plus base 2. Change colors here so our parentheses match. Okay, so hopefully that was a quick review, and I hope that helps. Have a great day.